In this video, let's go ahead and practice adding fractions that have common denominators together. Another way of saying that we're adding fractions is that we're going to be finding the sum of fractions. Sometimes after we add, we're going to be able to simplify or SimpLEEfy, so let's make sure we go ahead and check to see if we can do that if they have common factors between the numerator and denominator. Let's get started. All right, so for number 1, we have 5, 6 plus 11, 6. So right away, we want to notice that we have common denominators of 6 here. So that means we can add these fractions just the way they are. We go ahead and just write one fraction here, and we go ahead and put 6 as our common denominator. And we have our numerators of 5 and 11. So we're just going to go ahead and add 5 plus 11 on top. Now 5 plus 11 is going to be 16. So we're going to have 16 over that 6, which was that common denominator that we liked so much. And while now we have successfully added these fractions, I think we can actually simplify this one. Now think about how 16 could be rewritten if we break it down. Now 16 is the same thing as 2 times 8, but 8 is the same thing as 2 times 4, and 4 is the same thing as 2 times 2. So 16 really can break down into 2 times 2 times 2 times 2, or its prime factorization. Now for the 6 on bottom, that can break into 2 times 3, that's equal to 6, so that's its prime factorization. Hopefully we can see here that we have some common factors of a 2 and a 2 in the numerator and denominator. So that's the GCF, or greatest common factor, for the numerator and denominator. So what we can do here is go ahead and divide both the top and bottom by 2. And if we do that, then on top, we're just going to be left with 2 times 2 times 2, which is going to be 8. And on the bottom, we just have this 3 left. So that's going to be 8/3 as our most simplified fraction. Now, if you want to go ahead and write this as a mixed number, you can also say 3 goes into 8 2 times with 2 left over. So you can write 2 and 2/3 if you would like to write this as a mixed number instead of an improper fraction. All right, let's check out number 2. For number 2, we have 14/3 plus 11/3. So notice we have common denominators, which means that we can go ahead and just add these fractions just the way they are. Our common denominator is going to be 3. So let's go ahead and just put a 3 in the denominator here. And we can go ahead and add the numerators of 14 and 11 together. Now, 14 plus 11, that's going to be 25. So we're going to have 25 over 3. Now, if you try to write these numbers out with their prime factorizations, 25 just breaks into 5 times 5, and 3 is already prime, so we can't do anything about that. So this would be our final answer here. Now, if you want to go to an improper fraction, to a mixed number rather, 3 fits into 25 8 times, because 8 times 3 is going to be 24, with 1 left over, so we can say this is 8 and 1/3. All right, so we couldn't simplify this, but we could write it in 2 different forms if we would like to. For number 3, we have 17/4 plus 11/4. Notice we have common denominators of 4 and 4 here, so we can go ahead and just add these fractions the way they are. So we're going to go ahead and put that common denominator of 4 on bottom. On top, we have our numerators of 17 and 11, which we can go ahead and add together. 17 plus 11 is going to equal 28, so we're going to have a numerator of 28, and we have our common denominator of 4. Now this one's pretty interesting just because 4 goes into 28 perfectly evenly. So 4 into 28 goes in 7 times. So you could also say this is going to be 7 wholes, or 7 over 1, which of course can be simplified into just being 7. For number 4, we have 11/10 plus 34/10. We have these common denominators of 10 for both fractions. So we can go ahead and add these 2 fractions right away. On the bottom, we're going to keep that common denominator of 10. And in the numerator, we're going to have 11 plus this 34. Okay, so 11 plus 34 is going to be 45. So our numerator is going to be 45, and our denominator is going to be 10. Now, I think that we can go ahead and simplify this just because they have some common factors. Now, 45 can break into 5 times 9, and 9 can break into 3 times 3. So we can have 3 times 3, which is 9. 9 times 5, that's going to be 45. And for the 10 on bottom, we can break that into a 2 times 5. That would be 10. Now, do we have any common factors here? Well, you can notice here that they both have 5. So we can go ahead and divide the top and bottom both by 5, or cross them both out. In the numerator, 3 times 3, that's going to equal this 9. And in the denominator, we just have 2. So we're going to keep a 2 on the bottom. So 9 and 2, they have nothing else in common. This would be our final answer as an improper fraction. Or if you want to write it as a mixed number, 2 goes into 9 4 times with 1 left over. So that's going to be 4.5. Here's number 5. For number 5, we have the fraction 9/12 plus 18/12. So we have common denominators of 12 and 12. We can go ahead and just add these right away. Let's go ahead and put our fraction bar and put a 12 on the bottom. Keep that the same. And on top, we have 9 plus the 18. All right, now we can go ahead and add those numerators together. So 9 plus 18 on top is going to be 27, and the 12 on bottom is just going to stay the same. Now let's see, do we have anything in common for the top and bottom? I think we do. Again, we always got to check, but 27 is 3 times 9, 3 is prime, 9 breaks into 3 times 3. So here's the prime factorization for 27. For 12, we can say that's what, 2 times 6, and 6 breaks into 2 times 3. So 2 times 2 times 3 would be 12. Are there anything in common here? Yeah, I think we have 3's on top and bottom. So if we go ahead and divide them both by 3 or cross them out, on the top we have 3 times 3 left, that's going to be 9. And on the bottom we have 2 times 2, so that's going to equal 4. So as an improper fraction, this would be our most simplified answer. As a mixed number, 4 goes into 9 2 times with 1 left over, so that's going to be 2 and 1/4. For number 6, we have 7/15, and we're going to go ahead and add 28/15. So we have common denominators of 15. So let's go ahead and write this as one fraction. So that's 15 on the bottom, and we have 7 plus this 28 on top. Okay. Now 7 plus 28, that's going to equal 35. So that's 35 over this 15. And these look like they're both divisible by 5. Hopefully that's something you can notice too. So we can write this 35 as 5 times 7. And on bottom 15, you can write that as 3 times 5. Okay. Now, what do they both have in common here? They can both divide by 5. If we do that, we're going to be left with 7 on top, and we're going to be left with 3 on bottom, nothing else. Okay, so this would be our final answer as an improper fraction, but we could also write this as a mixed number. So 3 goes into 7 2 times. 3 times 2 is 6, with 1 away from 7, so that's going to be a remainder of 1. So 2 and 1/3 would be also our answer written as a mixed number instead of an improper fraction. Let's go ahead and see what else we got here. For number 7, we're adding this fraction of 4/9. I'm going to go ahead and add 15/9 to that. So we have a common denominator of 9. Let's go ahead and put that 9 on the bottom. And on top here, let's just go ahead and add this 4 and 15 together. Now 4 plus 15, that's equal to 19. So we have 19 over 9. Okay, and I think 19's prime, right? And then 9 only breaks into 3 times 3, so they don't have anything in common besides 1. So we could write this as an improper fraction, leave it alone, or we can say as a mixed number. 9 times 2 would be 18, which is 1 away from 19, so we have a remainder of 1. So 2 and 1/9 would be the mixed number version for this sum. For number 8, we have 17/8, and we're going to go ahead and add 23/8 more to that. So let's go ahead and add these. They have common denominators of 8, so let's just keep that 8 on the bottom. Now in the numerator, we're going to have the 17 plus 23. If we go ahead and add 17 plus 23 together, I believe that's going to be 40. So it's going to be 40 over 8. Now this one's pretty interesting. We had one similar earlier, like in number 3, but it just so happens that 40 divided by 8 is exactly 5. So we can also say this is going to be 5 over 1 if we divide them both by 8. And we can say that this actually comes out to just being a whole number of 5. All right, here is number 9. For number 9, we have this fraction of 23/4. We're going to add one more fourth to that. So we have common denominators of 4 here. Let's go ahead and just draw one fraction bar and put a 4 on bottom. In the numerator, we have 23 plus 1. We're going to add those two numerators together. 23 plus 1 is going to be 24. So it's going to be 24 over this 4. Just like in the last one, actually, 4 goes into 24 perfectly. It goes in 6 times. So this is saying this is really 6 wholes, or 6 over 1. And so if we go ahead and simplify this more as a whole number, this is just equal to 6 wholes, or 6. In number 10, we have the fraction 25/9 plus another 31/9, so they're both ninths. And if we go ahead and add these together, in the denominator, we have a common denominator of 9. In the numerators, we have 25. We're going to be adding 31 to it. So 25 plus 31, I believe that is going to be 56. Let's go ahead and add these. That'll be 56. And then we have that common denominator of 9 that just stays the same. Now, I don't think these have anything in common. 9 just breaks into 3 times 3. 56 breaks into 7 times 8, but then the 8 breaks into 2 times 2 times 2. So nothing in common here. So this would be our final answer. We could also write this as a mixed number though. I'm thinking 9 times 6 is 54. So it goes in 6 times, that's 54. That's 2 away from 56. So the remainder is going to be 2. So we have 2/9 here. Okay, so 6 and 2/9 would be the mixed number version for this sum. For number 11, we have 9/16. So our denominator is 16ths here, and we're adding 31/16. Let's go ahead and add these together because they have common denominators. Okay, we're going to put 16 down here, and we're going to have 9 plus 31 on top. 9 plus 31, that's going to be 40. So it's going to be 40 over the 16. And let's see, I think we can simplify this, right? I think this 40 we can break into 2 times 20. 20 can break into 2 times 10. 10 can break into 2 times 5. So this would be the breakdown of 40 here. For 16, we can break that into 2 times 8. 8 can break into 2 times 4. 4 can break into 2 times 2. So these would be their prime factorizations. They both have a 2 in common. They both have another 2 in common and another 2 in common. So I think all that we have left here is going to be a 5 on top and a 2 on bottom. So 5 halves would be our most simplified improper version. But as a mixed number, we can also write this as 2 and a half. That's the same thing as 5 halves in a different form. For number 12, we have 25 over 7, and we're adding 37 over 7. So we have this common denominator of sevenths. Let's go ahead and do that. Keep the denominator of 7. We're going to go ahead and add 25 and 37 together. I think 25 plus 37 is going to be 62. Let's go ahead and write that as the new numerator. That's after they've been combined. So 62 over the 7 here. Okay, and I think they are relatively prime, where they have no common factors, just because 7's prime and doesn't go into 62. So I think this is our final answer, but as a mixed number, 7 times 8, that's going to be 56. 56 is going to be, I think, 6 away from 62. So our remainder is 6, and then we have over 7. So I believe 8 and 6/7 is another way we could write our sum here. All right, here is number 13. For 13, we have this 27/6, and we're going to be adding 13/6. So we have 6 as our common denominator. And so let's go ahead and draw our fraction bar and keep our denominator of 6 here. We're going to add those numerators. So we have 27 plus this 13. Now, what is 27 plus 13? I believe that's going to be 40. Let's go ahead and put 40 over 6. And I think we can simplify this. They're both even numbers, right? So keep in mind 40 here. If we break that down, it's 2 times 20. 20 is 2 times 10. 10 is 2 times 5. And now for the 6, that breaks into 2 times 3. Just because they're both even numbers, we should be able to divide them both by 2, which we can here. So we can go ahead and cross out a 2 on top and bottom. On the top here, we have 2 times 2 times 5. 2 times 2 is 4 times 5. That's going to be 20. And then on the bottom here, we just have a 3 left. So we have 20 over 3. And so that can't be simplified anymore. So that's our final answer. But if we're looking for a mixed number, we can say 6 times 3 is 18, which is 2 away from 20. So it's going to be 6 2/3. That would be the mixed number version for the sum here. Okay. For number 14, we have 25/14. We're going to be adding 34/14 onto that. So if we go ahead and add these two together, we're going to have our common denominator of 14, which is nice. And then we have our numerator of 25. We're going to find the sum of that with 25 and 34. Now 25 plus 34, I believe that's going to be 59. So we're going to go ahead and write the sum of 59 over 14. Okay, I think this is simplified just because 14 breaks into 2 times 7. 7 doesn't go into 59 and 2 doesn't go into 59, so we're kind of stuck here, which is fine because that's just meaning that's our final answer here. And how many times does 14 go into 59 since this is an improper fraction? 14 times 1 is 14, 14 times 2 is 28, 14 times 3 is 42, 14 times 4 is 56, which is only 3 away. So I think we're going to say it goes in 4 times, that's 56, that's 3 away, so that's a remainder of 3. So we have 4 and 3/14 would be our mixed number version for our sum here. All right, last couple. For number 15, we have this fraction of 37/12, and we're going to go ahead and add on 45/12 to that. We have common denominators of 12 here. Let's go ahead and put 12 on the bottom. And let's go ahead and add these numerators of 37 and 45. Okay, now what is 37 plus 45? I believe that's going to be 70 plus 12. Is that 82? I'm getting 82 here, I believe, over 12. Okay, so they're both even numbers, so we know we can divide them both by 2. I think that's going to be pretty much it though. So 82 is the same thing as 2 times 41, and 41's prime, so it's kind of stuck, so that's fine. 12 is 2 times 6, and 6 is 2 times 3. So it looks like the only thing they had in common here was these 2's. So we can go ahead and divide them both by 2 and cross them out. We're being left with 41 on top, and then 2 times 3 is going to be 6 on bottom. So I think this is going to be our improper version. If we want the mixed number version, we got to see 6 into 41. 6 times 6 is 36. I think it's 5 away from 41, so we're going to put and 5 sixths here. So 6 and 5 sixths would be another way of writing our solution. If we go ahead for number 16 now, we have 36 fifteenths, and we also have 47 fifteenths. We can go ahead and add these. It's kind of nice, they have common denominators. Let's go ahead and put 15 on the bottom. Don't do anything with that. On top we have 36 plus this 47. So what is 36 plus 47? Well, the sum of those is going to be 70 plus 13, so it's 83, I believe. It's going to be 83 over 15. Now 83 is a prime number, and so that means it's not going to be simplified with that 15, because 15 breaks into 3 times 5, which are different prime numbers than 83. So I think this is actually done in terms of the improper version of this sum. But for the mixed number, let's see, 15 times 2 is 30, 15 times 3 is 45, 15 times 4 is 60, 15 times 5 is 75, 15 times 6 would be 90, which is too much. So I think we're gonna go with 5 here. It goes in 5 times. 5 times 15 we said was 75, which is 8 away from 83. So our remainder is gonna be 8, and our denominator is still 15 here. So 5 and 8 fifteenths would be our mixed number version for the sum. So there we have 16 different practice problems where we practiced adding fractions with common denominators. After you add the two fractions where you only add the numerators, you got to see if they have, the numerator has any common factors with the denominator to cancel out and simplify a little bit there. So hopefully you can see the difference where we could versus where we could not, but knowing your prime factorizations and divisibility rules can really help out with that. If you found this video helpful, please consider sharing with a friend or classmate who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.